Okay, we're going to start on 1D notes, dealing with arcs of a circle and the central angle in their relationship. So in a plane, if we have an angle whose vertex, remember that's the point of the angle, is the center of the circle, and it contains two radii, is a central angle. Pretty easy to understand. A central angle has its vertex in the center. Another piece of this is an arc is the part of the circle is measured in degrees, and the total sum of all the arcs will always be 360 degrees. Okay, that's kind of a nice number to remember as we go through. So how do we find the measure or the relationship between an arc and its central angle? Well, I've got this whole statement written out here. The measure of an arc is equal to the measure of the central angle. Okay, let's look at a couple examples. So we have three different kinds of arcs. One is called a minor arc, and that's always going to be less than 90 degrees. Sorry for the pause. I think I misspoke here. This is not less than 90. Okay, a minor arc is less than 180. Major is going to be between 180 and 360. A semicircle is going to be exactly 180. So if I look at my example here, a minor arc is going to be less than 180 degrees. Okay, 180 is halfway around the circle. When we name a minor arc, we always use two letters. So such as this example here, arc AC. Now it's kind of hard to see there. I'm going to kind of explode this out here. AC, and there's an arc like this. Okay, so arc AC. Man, I could have just put that there. Goofy. The measure of the arc is going to be equal to its central angle. This angle right here with its vertex on the center is a central angle. So angle B is going to equal 110. So that means arc AC is going to equal 110. Okay, they equal each other. On this one, a major arc is between 180 and 360, so it's going to be one of the larger ones. And when we name a major arc, we always use three letters. Okay, so in this case, D, F, E. And when we name those three letters, we are naming them in the order that we go around the circle. So I'm going to start at D, I have to go through F, and stop at E. So around the circle, I start at D, I have to go around through F, and I end at E. Okay, that symbolism there tells me to go the long way around. If I just had DE, that would be this minor arc. So this helps us know which way that we're going. Are we doing this little piece here? Or are we doing all the way around? All the way around is a major arc, and it's going to be symbolized by three letters. If we want to find the measure of that measure of that arc, we can see that this one is 60, so that means DE is 60. So the measure of the rest of the circle, that arc, is going to be 360 minus the 60, or 300 degrees. So arc DFE is going to be 300 degrees. We measure the arcs of a circle with degrees. So a semicircle is equal to exactly 180. That's a great number to remember in lots of different things we do. So a semicircle is usually represented by three letters, just like the major, and it tells us really which way to go. So this one is going to tell us to start at J, go through K, and stop at L. This one is going to say start at J, go through M, and stop at L. So sometimes it's going to make a difference on which way you go. Okay, and as I said before, the measure of each of those, the measure of a semicircle, is always going to be halfway around. When I look at this, the measure of an arc formed by two adjacent arcs, in other words, two that are right next to each other, is the sum of the measures of two arcs. We did this last semester when we talked about segment addition. We talked about angle addition. This is arc addition. Basically, I can add little arcs together to get a big one. So let's just take a look at this example one here. So you can see I've got several different things to look at. I would encourage you just to look at this first before you even try and find the measures of anything. because I can see here that this one is 90, so I know BC equals 90. This angle right here, DFA, is 50, so that's going to be 50. Well, A over to B, that's a semicircle, so that's got to equal 180, so that makes this one 40. I got vertical angles here, so 50 makes BE 50. And this is also a semicircle to equal 180. So 180 minus the 50 is 130. So you can find all the arcs, all the angles. Remember, the angles and the arcs are always going to be the same. So now we come over here and find them. So B to E, that's a little short one, is going to be 50 degrees. This one, I want to start at C. I want to go through B and stop at E. Okay, so this one is a little bit weird just because of it's going to be less than 180, even though it's got 3 letters. So C, B, E is going to be 90 plus 50. So that arc is going to be 140 degrees. ACE, we're going to start at A, go through C, and stop at E. Again, use some of those common ones that you're used to. So here is 180 plus this little piece here is going to give me the angle or the arc degree for ACE. Last one, they tell me that this angle EAD is 42, so I know this one is 42. I know these are both diameters, so 180 minus the 42. Let's see if we can do that there. We're going to have 138 for these here. B to C, that arc, if you have an M in front of it, we're finding the measure of that. That's 42 degrees. CBE, okay, that's 180 degrees. EDB, so E, go through D, there's 180 plus 42 more. 180 plus 42 more. Oop, 2. Good grief. 222. And my last one, arc CD, is 138. So if you go over to the circle and find everything first, finding the angles that they're asking you to is a whole lot easier. If you have any questions, let me know.